Hi everyone, so today we're going to talk about the composition of functions. So another method used to combine functions is the composition of functions. So in a composition, the results of one function are used to evaluate a second function. So there are two ways to do the notation, as you can see on the screen. And the way that we read this is f of g of x. So we just want to be careful that it's not actually the multiplication. It looks like a degree sign almost, but it's not an actual filled-in circle. So the thing to remember is when we evaluate a composition, we always want to work from the inside out. So let's look at some examples together. So given that f of x is equal to 2x plus 5 and g of x is equal to x cubed minus 2x plus 3, we want to evaluate the following. So here we have f of g of 2. So we want to start from the inside and work our way out. So our x value is the 2, so we want to evaluate g of 2. So we're going to take our x value of 2 and plug it into our g function. So when we simplify and do our correct order of operations, we will see that we will get an answer of 7. So now, remember that the g of 2, which we evaluated, now becomes 7. So we're going to use that value to evaluate our second function, which is our f function. So I'm going to choose my f function, substitute the 7 in for the x, and then do my order of operations to get 19. So I will see that f of g of 2 is equal to 19. So here we have two functions. Now notice in this example, we don't have a value for x. So what we're going to do is we're going to evaluate one function and put it into the second function. So here is our composition notation. You see that open circle, it's not a multiplication. So this is the same thing as me writing g of f of x. So what we're going to do is we're going to take our f of x function and we're going to substitute it into our g of x function. So here's my g function, and in that spot of the x, I'm going to substitute and put in that 5x plus 4. So now what we can do is we can distribute that 2 into the 5x and to the 4, and then combine my like terms, which is going to get me a final answer of 10x plus 1. Now here's an example of doing the composition of f of x. So you can write it in either way if you're more comfortable with the second notation. So we're going to take our f function and plug it into our f function. So here's my f function, and in that spot of x, I'm going to substitute that 5x plus 4, which is going to get me the 5 and distributing into that 5x plus 4. And remember, don't forget that second plus 4. That's part of our original function. So doing distributive property and then being able to combine my like terms, I'm going to get 25x plus 24. So in this example, we're going to use the graph that is given f of x and g of x to evaluate the following. So make sure you're looking at the correct function when you're doing your evaluating. So the first example, we have f of 0, and then we're also adding g of 0. So I look at my 2 points, and I notice that f of 0, where my x is 0, I'm going to go up to the blue, find my point, I get 2. And then the g of 0, again, I'm going to go to the x of 0 and then go down to my red graph, which is g of x, and I'm going to see that I get a negative 4. So I'm going to take those two values that I had, 2 and negative 4, and the operation is to add them, and I will see that I would get an answer of negative 2. The next example, I have an x value of 5 for both of the functions. So I'm going to look where 5 is, and I'm going to go to f of 5, which is 2, and then g of 5, which is negative 3. I'm going to multiply those two together, which gets me a final answer of negative 6. So the next two examples are my composition. So I'm going to look at my x value, and I'm going to work from the inside out. So I have to find g of 5 first. So I'm going to see my purple dot. I actually also get a negative 3. So my g of 5 is 3. And then the second function I have to evaluate is the f. So now I have a new x value, which is negative 3. I'm going to my blue graph, and I'm going to negative 3, which has a value of 2. So we do the same thing with the last example. We have an x value of -6, and I have to evaluate it at the f function. So my green dot I have with a y value of 4. So there's my new value. So I have to evaluate that with my second function, which is my g function. So again, I'm going to go to my g function with my new value, which is 4. I'm going to go down, and I'm going to see that I have a value of -3. So here are some things for you to remember. Make sure you're always starting from the inside and working your way out, depending on what the function is. And with a graph, make sure you are looking at the correct function. I hope this video was helpful and you learned how to do the composition of functions. Thanks for watching and have a great day.